All right, welcome to the seminar today about Site Tools Understand. We'll be talking about historical DevOps. A lot of new knowledge. We will be looking at something new, something different. I think something that's going to change a little bit the way we review our software. And also a lot of things that we thought were not possible in the past that we can actually now do fairly easily. This is a non-participating seminar, so you won't be able to talk, but there is a questions box in which you will be able to put questions if you need to. So don't hesitate to send questions there. I'm not a recording, I'm live. Before we start, I'm just going to introduce myself. My name is Stephane Raynaud. So I do work with Emenda in North America. I am an expert in Site Tools Understand. I'm also the person that created this demo. So I will be, able to answer a lot of questions if you have. I do see there is a questions, and yeah, good morning. So I do believe everything should be working at that point. I had one issue this morning, but anyway, so I'm an expert, I'm a technical guy, so don't feel free to send some questions or anything. So we are going to talk about something based on Site Tools Understand. And Site Tools Understand is a tool I believe everybody here would know. It's probably how you get invited here. Just in case you aren't familiar with Understand, it's really the best tool for developer to read code. And we all know that reading code is more difficult than writing it. So Understand is going to be the place in which you can simply put or read code, analyze code, and create mental map of how the code work, what calls what component depends on what component, all the way to where you will be able to do what's called rubber ducking, meaning the end goal with Understand is going to be able to explain to people what the code does. And rubber ducking means you can do that on the little figurine that is on your desk. You are able to explain to him as a or to any coworker how does that tool work. And Understand is a great tool to gain insight into a code. So today we are going to focus into Openssl. Openssl is going to be the source code that we use as an example to explore historical DevOps. And Openssl is a cryptography library. It's well known. It's famous for a lot of good things, but also for a lot of bad things. One of the biggest thing about Openssl was the Heartbleed bug. It was in 2013, and we all heard about it, right? The ability to use a buffer overflow to gain access to private keys. And once you gain private keys, well, guess what? You gain access to pretty much anything nowadays. So we're going to explore Openssl. We're going to apply historical DevOps to it, which is a mix of history and DevOps. I'll be talking about it. And just one note, I am not myself an Openssl developer. So that means that I don't know much about that code, but with Site Tools Understand, I was able to explore it and really gain some really good insight on it. So let's just look quickly at something. Openssl, what I have been looking at here is a product that have been evolving for 20 years. It actually went down to even more than that. But I have just limited my analysis from 2002 to 2022, so over 20 years of version. And so Openssl has like 8 major releases from 0.97 in that time frame to 3.0. Each of the version is basically broken into subversion, all named by a letter. So you go from 097A to 097B to 097C, 097D. And during those 20 years, there was 144 version. And those correspond to git tag, actually. That's the way I've been working at. So we have 144 different versions going over time. And the question is, today, is that we all know our code. We know one version of the code. We look at one version of the code. But, maybe we are interested to know a little bit more about the history. The history is meaningful. There is things we can learn from there. And if you look at, just simple question, if you look at version 9.8, what happened between J and K? What were the change? Well, we always have like a release note to explain to us what it is, but sometimes we just want to look at that code and we want to see the difference, what happened here. In 2015, which actually was one of the worst years for Openssl, and we'll discuss that later, there was 4 different versions running or being operated on at the same time. 98ZH, 1T, 11Q, and 101E. I mean, there was, and 102E, so there's a typo in the thing. But so the point is, like, what happened there? What was the difference between those versions? You don't have those answers easily today. So we're going to explore that, and we're going to explore a little bit the 144 version. So more specifically, there was the hard bleed, and the hard bleed happened in 2012-2013 timeframe, and it was from version 101 to 101G. And what happened there? How was it created? What was the root of it? Simple question. Well, let's try to answer this. So to answer this question, what we really want to know is, what happened between version 1H and 101, right? This is the 1H was released in March 12, 2012. And the 101 was released in March 14, 2012. It was a major version, but what exactly happened here, right? And wouldn't it be great if we could actually see what happened there? So let's do this actually. Let's try to see what the new feature in Understand that lets you compare one version with another, one analysis with another, that, let's see what that looks like, what we can learn from this. Can we actually see the hard bleed the way it was created? So I'm going to open Understand here, which is version 6.0 of Understand, 6.2 actually. And then we're going to do exactly that. We're going to open a project, and we are going to open, you can see I have all the version here, and we're going to open version 101, which is the first one with the hard bleed. Now, when you actually go and look at Understand project, I mean, we know that it's something to do with memcopy and memcpy, right? So we're going to look for memcopy. Memcopy is not a function defined in the project, so I'm going to have to show the unresolved entity by adding a filter that removes that, and then I'm going to look at memcpy. This is my main, the function that was doing the buffer overflow. So, and I'm going to do just a call by on it, which basically is going to give me, guess what, all the function in 101 that actually in version 101 that are calling memcopy. And there is quite a fair amount of things. And the bug is somewhere there. Well, with Understand, what you can now do is that saying, well, I'm version 101 here. Well, but let me compare this to a different version. And if you have that project analysis, you can do just that. So I can hit compare here. I select comparison project, and it let me select the project to which I want to compare. And what we said was that we want to compare to 100H, which is the last version we know of, or the one that was just released in 1.0 before the 101. So I'm going to say, okay, compare this. So comparing 101 to 101H, 10H, sorry. And then I'm going to select here the variant. I'm going to select the variant. I'm going to select the compare variant. And now I have a different graph. And what it is comparing the call graph before versus the call graph after. And so if you look at this, everything in green here were calls that were added. Every function that is in green is function that were added. The functions that are in bold here are the functions that have changed. So if I click on this, see, I can see the code. It did not change. If I click on this, it's a function that's added. if I click on this is a function that has been modified. And really, by doing this, you can actually, look at, and you would find easily that this is actually the method that was creating the heartbeat. The heartbeat was in this specific method, and that was a method that was added. So it's just like providing you so much more hint about what happened here between one version and the other. But is it really better than what we can do with a Git diff? I mean, whenever I talk to people about comparing project right now, everybody is going and talking about Git diff, right? Everything is based on looking at number of lines and lines that have changed and all those things. Is SciTools understand comparison feature really much better than just comparing line to line or comparing file to file? Well, you have seen obviously that, we have just looked at the code tree and we have seen how a code tree change. But if you push that to even more advanced feature, let's go back to this, right? I mean, I can just simply look at a code and say, hey, what changed in it? Let's say I go and I look at the main function, for instance. I need to do this. I think it's just, whoops. There you go. There is all the main function in my project here, 101. How did it change? So a main is a good starting point, right? I can right click on that and I can do same thing, a call on main, right? And usually you will see the classic call, which is a call tree for the main function. But again, here you can do a compare. I can see everything that have changed in the main in the logic of my overall program between one version and the other. I have that ability to do that. Similarly, a call tree is one thing, but I can even do this with control flow now. Meaning I can have a compare control flow, again selected here, and I can see how the control flow of this function have changed. For instance, I had like extra code here that were added. I have a new path. Used to go like directly to doing an str comp. Now I'm doing a previous test here. There was a test added. So I can compare the logic of the code. It's just not comparing only line per line. So that's like something really like pretty good there. I mean, this is one way to look at it. There is another way you can look at it, and the compare has a lot of good comparison functionality. The locate change entity is a great one. It used to take like a long time to do this, but they have done an incredible job in 6.2, in which you can actually see every single thing that have changed in your code, changed, added, or removed. So, you look at the code and you're wondering what changed. Well, guess what? You probably want to look at functions, so let's filter that. We probably want to look at what changed, so let's filter that. So I'm looking at all the change function, and then let's look at the, percent change of the function. So this function has changed 100%. Look at this, it's completely different. This one, 92%. Yeah, it used to be a big thing, now it's really small. So you can actually see and identify different elements that have changed. These are function, classes, file. So a lot of comparison there, ability. You don't like a table like that? Well, you can also do similarly a change tree map, the same way you used to be able to do heat map or graphic visualization. Specifically, this is the one that I like, where in this case, you see every single function that have changed in the code, and the size is going to be based on the change in their cyclomatic complexity. So basically, like how many ifs and else have changed. This function here, there's 25 ifs and else that have changed, and there is 108 lines that have changed. So you can, again, same thing, looking at what changed, looking at what are the big things. I mean, obviously, those are actually big in change. There was a big change in this function here. It's really like, what's kind of interesting about that one is that it's a macro, and that macro had ifs and else in it, and it was kind of changed. So there was a huge amount of cyclomatic difference that have changed. So a lot of possibility to visualize for a developer what have changed in the tool by default. If you are like me, and if you really want to invest in understand, there is also the ability to create your custom graph, and we do have one that, please contact me and I'll actually share it with you, no problem. But there is one that I like to use, which is the comparison graph. And this actually show you, same thing. A call tree was different in main, except you can just focus on what changed. So this graph at this point is just going the element that have changed. Main, what have changed from one version to the other. Here you go. You have everything in a visual view. What is in red has been removed. What is in green has been added. What is in bold have changed. And you can do easy comparison on this. So think of it. Take a moment. Stop here. Look at, in your code from one release or one version, or your coworker worked on something, you want to compare a branch with another branch, and you want to see just what changed. That function main was working before. It's not working now. Well, something changed. What is it? Well, this is how you can answer that question really, really quickly. So think of it. How would you go about that today? How long would it take you to figure out the same amount of information? So let's park that for a minute. But I do sincerely hope that I have convinced you that comparison feature Untitled understand a little bit better than comparing line. So now I have used one version versus another version, right? I've compared one version of understand versus another version of understand. And I say there is an 144 version of Openssl. Did I actually analyze the whole 144 version of understand? Is it even possible? How long does it take? How did we do it? Right. And so far we have done what's called the historical part of this presentation, but hey, we may want to go toward the DevOps, an automated way, right? And this is what we have done with a few of my colleagues in Europe, and they have been really helpful with this. We have actually created a simple Jenkins server here in which you are able to go and you can build with parameters, and you can say, oh, it's Openssl. I'm going to do a git checkout from this. I'm checking out this version, and then I build. And then we have automated the full creation of, an understand project in a pipeline, in Jenkins pipeline. So what's interesting about this is that understand is the fast analysis. So it's going to make it real, and it's going to make it possible for you to do things like this. Let's look at the Openssl project. It's C code and it's 350,000 line of code, right? And if you look at the pipeline, the overall pipeline, in which we do checkout, we clone, we compile, we create a database, we analyze the database. The part that's interesting is what's highlighted in red here. And an analysis of 350,000 line of C in understand is about 40 seconds. The overall pipeline, because of the checkout and because of the compilation, which itself takes 1 minute and 43 seconds, we run about 4 minutes per thing. So analyzing the 144 version was about 9.6 hours. So compare that to your application, see how realistic it is. But, building a full repository, it's not that time consuming. I mean, it's not that time resource, and you do it once and it's done, right? You analyze the whole version, you're done. So how does that look realistically speaking? I want to point out, if you guys are on the GoToWebinar, you can see that there is handouts. I don't know if you can see the handouts. It's like where the chat box is. You should see handouts, and you should see 3 PDFs there. I really suggest you download them. One of them is the Jenkins configuration I used, that pipeline I just showed you. So something you can get inspired from. The other one is a document about how to build from a CMake build if you wanted to create and automate the creation of a database. It's like a script for Linux. And then there is useful links in which you can find my email address and other links that I will share later on in the thing. But so basically it is like an example of what I'm going to describe here. which is how do we automate in DevOps the build of understand. Well, it's simple. You start from the top, right? You use the set license code. You use the UND command line. You need a DevOps license to do this. So please talk to your salesperson about this. It's not always enabled. And the example I have here are all based on a compilation database, a compile command.json. This is produced by default by a CMake. If you do have a make, you can use Bear. Bear is a tool, it's an open source tool that lets you do a make command and then it will create a compile command.json. And then that's what we did here, right? We did the git clone, we did the git checkout. Openssl use make, we used Bear to create that compile command.json. After that, again, UND, you run a few steps. And now we have what's called the capability, which is the portability in the understand project file. So you can actually define some sort of name variable if you want. And in this specific case, we define it shows in red there, UND add root dependencies user. So we use that capability to point out this user, the system header to a directory we can change later. And lately in this example, we kind of like analyze the project and we zip everything in a zip file. That zip file will be something you can keep, and there is all the files you need in there and you can open it on your machine, which is what I did here. And the beauty about the way we have it set up here, and again, I recommend that it may be something you want a consultation with one of our experts or come to one of our training. But the beauty of this is that I am able, all that Openssl I did, all those analysis, I run them on Linux on a non-embedded place. And I can open them on Windows, I can reanalyze on Windows, or any machine that you have. So if you work in a non-embedded world, where things are like on a remote machine somewhere, I mean, you can actually run your analysis there and bring it over as a zip file. Size permitting, things like that. Again, things to discuss. It's not a one-size-fits-all, but the whole logic on how to do it is done here. So again, cross-compilation. I mean, isn't like brilliant? You bring like Linux projects, you get them, analyze on Windows and compared on Windows. So if you follow those steps, eventually, I really recommend build a huge database, a huge library of all your different versions. I mean, developer would love that. I mean, I'm hooked to it. Actually, like I keep downloading different versions of Openssl and trying to make sense of it. And if you don't have the time to build something, but you want to impress someone with this, right? I mean, go to blog.sciTools.com. There's my personal blog here with the same information. And you have both links, but go to blog.sciTools.com. And I just wrote an article for you guys. So it's here, right? You go to blog.sciTools.com and you see blog.sciTools.com, great place. A lot of people write a lot of interesting article. And we do have a competition, so please read mine. And there is one comparing Openssl here. And guess what? I have made that repository available to you guys. So if you want to download any of those versions, compare them, maybe read the CVE of Openssl, some things that interest you, compare it to the last version where they did the fix. They're all here. You can download. There is an explanation on how to do it. And if you want to get it all and get all the version, there is even a batch script here where you can download all the version of Openssl, all the thing. And like me, I have a directory in which you can have. Hold on, I want to show you guys. See, you can create that on your machine, right? One UND file into all of those different versions. Anyway, blog.sciTools.com, best way to do that. It's also in your PDF file if you have downloaded. So we have done what I believe is the historical, right? Which was the ability to compare two projects. And now, we have also done the DevOps, which is the ability to automate all this. Now the question is, let's put those two together and let's see what we can do, right? So, and the idea here is, what sort of information can I get? It's great. The developer can go and compare two things, make sense of it, stuff like that. But me, maybe at a higher level, what do I see? What did I learn? Is there anything different? Is there a new thing I can do with this? So remember, let's see if we can create some sort of dashboard showing us things, maybe get some information. So the first thing that's going to be great is that you can automate again, because, well, guess what? There is a command, which is UND export change. And that lets you just create a file that contains all those change entities, all those change between two things. And, you know, if the information you are looking for is not there, well, guess what? You can even script with Python and create script to compare project in a meaningful way. And I'm going to show you that later. But so if we only base on UND export change, what you're going to get is you're going to get files like this, right? Great things, which is like, you know, again, like think of what we saw in the GUI, right? You know, there is a function here, this is his name. He had 8 new line. Is 81% change. Oh, no, 0.81, I guess. Yeah, because it's like not much change, and his 8 lines that are different. That's actually doesn't make sense, but this new line. Okay, so there is 8 new line, 8 thing. We don't really know the size of the thing, but it will be easy to determine. So anyway, you have data there. And then what does that teach us? Or what kind of dashboard could you do with this? Well, it is one that's kind of interesting. I found that was one finding I had was interesting. If you look at Openssl over the year, between the 7th version, there was some overlap, right? I mean, they dragged the previous version a little bit in the time of the new version. So version 9.8, for instance, the first time was released was corresponding to 9.7G. You know, same things that 1.0, first time it came was 9.8N. And we have seen here earlier that 1.1, our bleed, was corresponding to 1.0.0H. So basically to get a fair idea of how much of a release that was, you know, you don't have to compare 9.7 to 9.8. You want to compare 9.8 to 9.7G, right? So, and by comparing those things, you know, I found it some interesting because we all use number of line now. A lot of people use number of line as like, hey, guess what? This is the way you do things. But like, look at those two graphs. One is showing you the number of lines that were added, and the other one the number of functions that were added. And while it's fairly, well, I don't know, there is like really something. Yeah, definitely 1, 1, 2, 3, 0. I mean, we can definitely conclude here we have a major release. But the gray one, you know, guess what? Like, I mean, a lot of lines have been added, but not a lot of functions. The green one, not much line has been added, but a lot of function have been added. I don't know. I mean, is gray bigger release than green, or is green bigger release than gray? I mean, it's all depends on what you do, but I just want to point out here that, you know, again, the line may not be the best way to measure the complexity of a release. But now you can, because you have metrics that you did not have before. And I think that's, you know, a little bit the conclusion that we'll have today, which is, well, there's a lot of new things you can do with this. And again, let me show you another example. Openssl, version 9.8. If we only focus on version 9.8, we go from A to ZE. That was the longest existing version of Openssl. And guess what? You look at H. Wow, H, something big must have happened. That's a major redesign. Well, no, not at all. Actually, if you compare it to the number of change function, which is in blue, you can see it was just like anything else. It was fairly basic. When you actually go and investigate, and again, I invite you to do that. Go and download 9.8H and 9.8G and do a comparison. And then you will see that it was actually kind of just someone changed an index on something, and so there were so many lines where, you know, instead of having an array and people access index 99, well, they were using access 98. So it's a complete screw up here in terms of like how you'd think that the version have changed compared to what it really realistically changed. It did not change that much. Similarly, you have to test software. Can we do better than what we have done today? Let me just go back to the graph I showed you earlier and say, hey, you know, a developer can look at this, right? Remember, this is the graph main, and I only show the change, right? And I'm like, this is what changed into my main call tree. right? Okay, well, I guess, with this, visually speaking, do I need to test this? Yeah, sounds like reasonable. I need to test that function. But, there is also a bunch of call trees in which maybe nothing has changed. I mean, the function main has not changed, but nothing has changed in the call tree. Do I need to test this? Probably not. Does that really impact my test plan? If I am someone that does unit test, do I really need to worry about that? Well, guess what? I did my own little research on this. And then what I did is I took all the main function in every single release on OpenSSL, right? And for each of them, I computed, hey, did the call tree change in that main? I mean, did main change? And did the call tree change? And then I repeated, automated this, little bit of Python, little bit of UND. And then I tried to get an accurate prediction of what needed to be tested. So compare all the call tree to all the main on all the version. You get a file that's like that. That's your raw data that you get out of the investigation we did. You get the main, it's built here. Is it the same content? Yes. Did anything change in the call tree? No. But for this one, the function did not change, but something changed in the call tree. And you can see, like, from OpenSSL 3.0 to 3.01, there's not much have changed. So what you get is, a little bit of Power BI, whatever graphical dashboard you want. This is what kind of it looks like, the Excel spreadsheet. Every black dot is something that really needed to be tested. But there is a conclusion on that one. If you had done blind testing, meaning you had tested every single main over the 144 release, you'd have to run 6,902 tests, about 7,000 tests. If you had decided that, well, I'm going to only test the main function that have changed. Did their code change? Yes, no. I test only the one I've changed. Well, you would have tested 318 main function, but you would have missed 399 change in the call tree. So things that could have impacted those functions. But realistically speaking, if I, and again, it's an analysis that took some time, right? Because every single time I open one version compared to the other version, compares the call tree for all the main. But it was fairly quick actually to compute, maybe less than 10 minutes. But conclusion was that you only really need to do 717 tests to test all the main function over the past 20 years. You did not need to do 7,000 tests. You only need to do 717. And that was 10.38, or about 10% of the tests were actually needed. Again, something not possible before. If you do any testing or any QA, think about that. Think about process that you can develop around historical DevOps, right? Your new release coming, what do you need to test? How would you decide that today? You go by line number? Yeah. You go by the content of a function have changed, even if you actually can see that. Did the file change? I need to test it. I think this is a lot more accurate. Okay, similarly, we can actually do the reverse. And people are all worried about security, CVEs, the bad guy coming in. People are doing a lot of checks on this, right? And the question is, how serious are you about it? A lot of people just use static analysis tool, perfect, run, give them a list of problems. Here is one thing I do see sometimes, which is there is ban function. And we talked about the R-bleed, really bad function, right? Mem copy, don't use that, right? But actually mem copy is being used everywhere in OpenSSL, and it's probably used everywhere in your code. So the problem is, you run a static code analysis on this, and then it says, oh, there is a mem copy here. It's used at line 153 on digest.c. Run a static code analyzer, your choice, and it says, potential problem here. Now you have a developer that go look at it. No problem, it's all good. And then he said, okay, ignore the problem at line 153 in digest.c. Forever? Is that a good move? Well, who knows, right? So remember that we have the ability and understand to show the difference between what happened and changed in the main function. But let's do the reverse. which is I can start from mem copy here. And again, I can do my comparison graph. But this time, I'm going to do the call by mode. So basically, instead of looking at what changed into my call tree, I'm changing what changed in my call by tree. So this is a function there where we flagged there was a use of memcopy, and you said, yeah, this call here, perfectly fine. No problem. We flagged it. We ignore it. Well, guess what? During version 101, HT101, 3 functions calling these guys have actually changed. A new function is actually calling this guy, which call this guy, which call this guy. Is it important? Do I need to actually pay attention to this? Is it a good sign or a good hint that maybe there is a potential problem there? You know, if I try to establish risk, how am I going? Is that useful information? Well, yeah, I was curious about it. So again, I did, my due diligence, and I actually ran through things. So what I did is I found a website that gave me all the ban function according to best software practice. And, there's memcopy, strcopy, sprintf, I2a, all that thing, right? And then same thing, from one release to one release, I checked, did their call by change? Is there things that have changed in their call by? And then I repeated it for every version. So I get data like this, which is strcpy from OpenSSL 3 to 3.1. Yes, there was change in the call tree that end up at strcpy. And actually, this one is big. There was 347 new function kind of calling in that tree that end up in strcpy. There was 49 remove. There was 159 link that were changed. Not going to go in details, but it's basically like, a function used to call a function 2 times, and I call it 3 times. And then the total number of function in the call trees that's calling strcpy was 10,848. And 313 of those changed. So I could even have some sort of an idea of, in percentage, what risk factor. But for every single function in that list, for every single version, I did this and I compared those things. And then I created metrics. So what was the conclusion? What was the finding on this? Well, again, no things that I can actually say for sure. You need to measure that and you get bug. But is it meaningful? Well, let's look at a few examples. Again, we go back to version 9.8 of OpenSSL here, and I've computed a risk factor, which is what you see in blue here, based on the version, right? A, B, C, D, E. And you can see that's kind of a level of risk based on how much change in the call of those ban function. And you see like a big increase at F, and about version J, right? Like it's those 2 places where there was huge risk. And interestingly enough, version F is the only one who introduced new CVE, new problem, security problem in the version 9.8. Most of the OpenSSL stuff was always like the problem was always created when there is a major release done. But in this specific case, there was CVE introduced in F. And not surprising, right? You have like a huge thing. I don't know of CVE here that were introduced, but doesn't mean they don't exist, right? Just means that they have not been found. But again, my point is more about comparing to the number of line. If you had actually just used number of line again, about, hey, what's my risk factor? Well, you would have definitely flagged H, not F, as your problem child, right? So another example, this one actually is pretty cool. It's in red, you see the number of CVEs, and CVEs is common vulnerabilities, and anyway, like basically like the bug we know that were critical to security, right? Worst year for OpenSSL was 2014, 2015, 2016. And here in red, you see, a number of problem in the release of OpenSSL at that time. And then in blue, you see the number of, or the relative size of the call by tree to those problematic functions. So basically, how big is the people that rely on those? And guess what? Hey, no problem here, right? We can see there is a good correlation between big trees, big number of calls to those banned function, and security problem, right? So there's a good correlation on that. Again, someone could argue, well, what happened after 2017? It looks like the numbers are still high, but there is no CVE. Well, CVE are known only when they are discovered. So it's fairly to assume that the past 4 or 5 years, some problem have been around that have not been discovered yet, maybe. So yes, I'm actually concerned about what was happening in 2021, 2019 in OpenSSL. Again, I can't really prove it, but there's a good feeling there. Demonstrate that some new metrics can give you some new highlight about things. Regardless, if you don't even want to go and do metrics and all those dashboard, remember one thing, it's good to do a quick check on whatever you put in your code. You have used version 1 of some sort of an open source project. You want to use version 2. Well, guess what? Analyze both. Make a comparison. 1 was working for you. 2 may have problem you don't know about. And I think it's important to do that, especially in a world where protestware is becoming a thing. I don't know if you heard about the guys that just, wanted to hide some virus into an open source and started erasing hard drive in Russia. That could happen to anyone, right? And even there was some article I read recently about can we still trust open source? Well, quick check is actually easier to do than ever. It is cheaper than ever. Take what you add, look at what's new, compare it. It takes a day of a developer to really look at that, and you can see what happened. Going through a log of line change is not going to be meaningful, but doing that is a great tool, great suggestion. One more thing as well, it's not all about time, meaning that all the presentation here, I have focused on things that are related to going from one version to another, in time. But you could also compare things based on configuration. OpenSSL 3.02 can be compiled with a flag that's called no error. So it basically does not load all the function name and reason text to reduce the footprint. And guess what? Look at this function. Simple. It's just like, you can see that we are not loading this. It just went there when you do a different build. So same release, but we can compare different versions. Know that there is a limited caveat in this right now, and I'm going to talk to some people about it. But the concept is that all the call tree and all those things will show you the difference of things, but the function will, if it's based on if def, macro compilation, then it's going to be it could lead to showing you a function the same based on the code. The code has not changed, right? Only the way it is compiled have changed. So know that there is a little bit of a limitation if you get there, but it is still quite useful to know, if you are investigating, what does that mean, no error? How is the code behaving different if I do this? Well, you can actually get those sort of visualization. So let me sum up what we have covered today. Site would understand has added feature to do comparison. Great. We put it and we analyze a lot of versions of a repository. Could be your application. We created that gigantic repository of all those versions of OpenSSL, providing realistically a time machine. That's why you have a DeLorean there. People who know me know that I'm always obsessed in putting that in every presentation. But we have a big repository of all the versions of OpenSSL, and we automated the build of that. It's possible for you to do that as well. And now we have an insight about, if you look at the top right here, that diagram, if you ask me any question about anything at any time or at any point, we'll be able to look at it together and we'll be able to know what changed from there to this. That leaves you with those 4 things at the bottom here, right? The first one, of course, is definitely code tree showing what have changed developer in one snap of a second. You can see what changed. You can also create dashboards that's going to help you do better strategies in your software, because now you have plenty of new metrics. And I don't know what metrics is relevant to you. Happy to talk about it. QA testing. I mean, you can really start automating what changed in my code. What do I need to test? And security. So you see, like, I think, it's like looking at a car that's, you go to buy a car and it's in a showroom and it's not moving. I mean, how safe is that car? Well, it looks like it has big tire, it looks nice, it looks like, it's good, looks the brake look good. Do you actually need velocity before you can actually really know how good that car is? Do you actually go on a test drive? Do you actually see how it behaves dynamically? And it's a little bit the same idea here, right? How did the software behave dynamically over the past 20 years versus the one snapshot you are looking at here, the one showroom you are being shown? Regardless, I hope I have showed you that it's better than Git diff. Again, I can probably looking for, arguing with people about this. But so, where do you start? There you go. I really, really say, look at the example I provide. I provide those PDFs there. Go sign up. Go talk to us about the DevOps training. Get someone on your team to integrate site tools understanding your build. This is the best thing you will ever do, because once you have all that repository of database, it's becoming addictive to actually go and look at the past of your product and comparing things. I showed you the Openssl page here. Go there, try it, start, seriously, go and enjoy. Download 2 things, put them on your dashboard. Talk to me if you need an evaluation to do that. Compare things. You see, it's fun. It's super fun. You can actually see what's happening in the code. So this is the critical first part. And we are going to do 2 types of training. There will be one if you want to have a team, your own private team. But we're also going to do like meeting, or like where you can have only 1 person of your staff. I think 1 is good enough to learn on how to build and integrate understand into the DevOps feature, into the DevOps environment. It's super easy to do. You have all the example you need in what I provide. But if you need help, we're here. Create that repository, make it available to your developers. I mean, it's like, at that point, I mean, demo that on your team next time you have a meeting, right? Demo the Openssl repository, show them how, that's cool, and see if they are interested in getting that. And then, if you want to develop more like business-oriented process, you can automate relevant, graph. You can automate dashboard, all this, again, we have a really good Python training now available. Again, same thing, you can do it for the whole team, or you can do it on a, kind of a shared basis with other people. And that will let you create so much, automation and different ways to view things, custom graph like I did, some things that may be even more relevant to your operations, such as, tracking component and how component change versus other component over time. So it's something you could do with a little bit of Python programming, customization. So anyway, that was it for today. So stay in touch. There's like plenty of email for me here. If you have never talked to me, don't be shy. There is a PDF there, the handout. Please download that. I mean, I think there's like some useful information in there. Go to the Openssl page, try it. Be in touch with your salespeople or your team at Emenda if you want more questions. I'm also available on a one-on-one session. Happy to do some follow-up and answer some question on this on a one-on-one basis. So I'm going to stay on for 5 minutes. If there is questions, you feel free to type them yeah, if there is a question, feel free to type them, and then I will answer. So I do have a question, which is, could you please share with me how to create the comparison graph you showed earlier? So yes, so the comparison graph, I can actually definitely send it. Download the useful link. You have my email address. Send it to me. I will send you the source code for that comparison graph. I mean, the call by and the call graph have the comparison feature in them by default. It's just the one I have here has a little twist, which is only show you what I've changed, right? But I'm sure there is a product manager I see on the call here. So you're probably going to add that to the tool at some point. But yeah, definitely I can share that to you. You can use it as is. If you want to start an understanding how this is done, I will recommend like doing a training with this on the Python. Also, I have a question. Which of the feature you show can be used with static analysis to any required dynamic analysis? So I'm not sure I understand the question, but look, one thing I have not done, and which would be actually super brilliant, is we do our own analysis. So Understand does its analysis. It doesn't really, it does static code analysis, right? So it's just the analysis, and then you do the comparison, you get all those metrics. What I have not done is used another third-party tool that basically like will count the number of defects or something into a tool and compare with those metrics and try to find the correlation between the two in order to deduce, hey, this is bad code, this is good code. I really want to do, and I'm going to spend some time doing some more research on this. Because again, those features are like, you know, not that old, right? So it's a brand new thing. And I think the best use of your time right now, put Understand into your build process. And eventually there's a lot of good things coming out of this. So, and there is no, again, if the question is about dynamic versus static, well, remember, Understand doesn't do dynamic. It really just read code. So, and that's also a beauty of it. It's just, it doesn't do dynamic analysis. So if you can only do static analysis, Lisa, then no problem. I mean, this is, you can, you get the code, you analyze it, it's self-contained in Understand. As I said, we can even, if you run an analysis on a Linux machine, you can just zip everything together, bring it, and then you can actually like open it on your machine. Look, all those Openssl projects have been analyzed on a Linux machine. Well, guess what? Open them on your Mac or your Windows, you'll see they work. So you don't need to have binaries to do any sort of analysis here. You really just, it's only purely static here in nature. So no, we don't require any dynamic analysis. That's the question. No, this is like, you know, guys, it's like, you know, as a developer, I am excited about this. I am, you know, it's something I wanted to see. If you, again, do me a favor, take an hour of your time, right? Go to the Openssl CVE, find a CVE of Openssl, and they tell you when it is introduced and what it is fixed. Now you go, you download the version that corresponds to that. You do the diff, and you will understand in about 5 minutes what happened, how they fixed it, and what caused the problem. And as a developer, it's something that, you know what, like, someone else would probably have a lot of trouble to explain it without this tool. But again, there is the cost of entry. The cost of entry is to be able to build, Understand project correctly. That's why I'm saying, put it in your build process. Any other questions? I ran out of questions at this moment. So. Anyway, be in touch. If you think about something, I hope it was eye-opening. We do have another session at 2 p.m. Eastern. If you want to bring a colleague because you thought it was great, I will do the same exact seminar. And if you have more questions, I'll be able to answer them then too. So. All right, well, thank you very much for your time. I hope you enjoy this. There is a recording available. I will make that available to people that request it as well. So, hi. Well, thank you very much.